Hello students, welcome back. I completed this entire notebook, so I thought, but it turned out that I skipped a couple of topics, so I came back. One is this issue here. When I talked about everything about histograms, I missed this part. Types of histograms. I got it from an elementary textbook, so the picture is not very good, but please remember the terminologies here. This thing is typically called symmetric, as you can see. If you draw a kind of vertical lines around here, and the left and the right are pretty much the same, in that case we call it symmetrical. And then triangular, it looks kind of like triangular, so that too is a good term. And is it really normal? I'm not so sure. But as for what a normal type is, that's something we are going to discuss several weeks later, so let's postpone that. Personally, I'm not going to call this one normal. It doesn't look like normal. You have to have some further stretching out to the left and right to be called normal. It is certainly symmetrical and triangular. Next example here. It's symmetric, yeah, left and right seem same, but also it is kind of called uniform because the height is pretty much the same. Now it doesn't have to be exactly the same. Some maybe a bit higher or lower, but if they're more or less pretty much even on top, it's called uniform. And then rectangular, I've never heard anybody talking about rectangular shape. Triangular I have, but rectangular I've never heard about it. Uniform is well-established name. Now, key is this: skewed to the right and skewed to the left. What do you mean by that? Skewed or stretched to the right here, and skewed or stretched to the left. So start from this kind of symmetrical shape, and then take this right-hand side part, stretch it, and then left-hand part, compress a little bit, and this is what you get. So skewed to the right and stretched to the right. And then J shape, this is not really important. Another thing that everybody should remember is bimodal or multimodal. And this thing, peak, the peak. So, alright, let me write it like this. So, skewed to left or right means stretched to so that's something to remember. Stretch, stretch. Now another thing to remember is mode. So here, mode is this peak. Most of this one is peak. And then mode of this one is right here. And mode is right here. And here mode is, well, either all of them is mode or this uniform. Now, this one, and that one, and also this one. And they have only one mode, right? Maximum here, maximum there, maximum, maximum, or if you rather call local maximum. So, if there's only one local maximum, we call it unimodal. So here's a local maximum, local maximum, local maximum, local maximum. But here I have two local maxima. One here, and then maybe a little bit smaller, but here as well. This one looks like absolute maximum, and this one is not absolute maximum, but still two local maxima. 2 bimodal to local maxima. So multimodal means multiple local maxima. Those are the kind of terms you should remember. Alright, one further question. Now let's look at the symmetrical histogram, and then can you pretty much guess where the mean is? Well, that's easy. Mean must be right in the middle. Okay, alright. And where do you think is the median? That too must be right in the middle, right? That should not be too difficult. So the first picture, in the first shape, in the triangular one, we have this. Mean, mode, and median, they're all the same. Or this is statistics, nothing is ever precisely equal. So let me use a little bit wiggly equality sign to mean they are approximately the same. But you can see all those. That's easy to see. Now, my real question is, what about the third picture? In the third picture, which is skewed to the right, or stretched to the right, mode is this one. Now use your common sense. Is the median greater or smaller? Median is obtained by just knocking off smallest, largest, and merging in, right? So this one is very close to the minimum, so it's going to be knocked off. They're going to merge in somewhere here. So here, you're going to get that. Do you see that from here? Now, how about the mean? And that's a bit harder to see. It turns out like this. Mean is even more skewed, more stretched. Why do you think it's happening? Well, think about an extreme case. Let's suppose I stretch this one much further, that simply take this last rectangle, keep the same, just cut it off and pull it all the way around here to the right. Will that affect the median? No, it's not. Because largest number, however large, they are going to be knocked off anyway, pretty soon. Is mean affected by that? Again, take this rectangle here, and then pull it all the way to the end. Mean is affected. If I pull it even further, the mean is getting bigger and bigger and bigger. So more skewed, mean is affected the most. I mean, mean is affected much more than the median, basically. So whenever you have some kind of skewing going on. Likewise, in the fourth picture down here, which is skewed to the left, this is the other way around, isn't it? Mode is here, median must be here, and then skewed to the left like this, so mean must be the other way around. Or let me write like this. This is skewed to the left, so like this. Let's write like this. So that mean comes to the left. So that's typical of skew to the right versus skew to the left. And then as for bimodal here, mean, median, they're going to stay around the middle. Not exactly symmetric, but not too difficult. I mean, not too different. But as for the mode, it is kind of splitting it in two. And then this one is absolute mode. If you say the mode, and then this is the one. And then this is local maximum. So local mode, I don't know whether statisticians use that kind of term. But if you say the mode, if you have just one mode, then you have to take this one. This one is not really a mode, but if you consider unimodal, bimodal, multimodal, in that case, this is also smaller, but it's a peak. So it counts as kind of mode 2. So local mode or local maximum, I can accept all kind of terms like those. But if anybody asks for the mode, it's got to be this one. Well, a lot of terminologies like those, and I mentioned all those because they appeared in homework problems, and that's the only reason. And as I said before, not very mathematical, maybe some intuitive understanding on this skew to the right, skew to the left versus mean media concept may be a little bit useful, but otherwise, I don't overemphasize, so I'm going to bury those in homeworks. Probably you won't have to worry about those kind of things in something bigger like exams or projects. Alright, that's about it. So much for additional topics, the topics that I missed. Thank you.